Question 15. The enthalpy change for the reaction shown in this equation is x kilojoules. The enthalpy changes for two other reactions are shown. In this question, we need to identify that the two reactions given below are partial reactions to the full reaction above. Looking at the first reaction, let's highlight it in blue. 1 mole of carbon reacts with 1 mole of oxygen gas to give 1 mole of carbon dioxide gas. We see the same reactants, carbon and oxygen, and the same product in the main reaction above. The second partial reaction is the reaction between hydrogen gas, oxygen gas to form water. Again, we see this partial reaction in the full reaction above, where there is also hydrogen, oxygen, and water. To solve this question, we need to align the partial reaction with the full reaction that we see above. So for the first partial equation in blue, we know that there are 2 carbon reactants in the full equation. So we should multiply the first partial equation by 2, where we have 2 moles of carbon reacting with 2 moles of oxygen gas to give us 2 moles of carbon dioxide gas. Similarly, for the second partial equation, we see in the main equation that 2 moles of hydrogen gas is reacting. So we should multiply the second partial equation by 2 as well, where 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to give us 2 moles of water as the product. We can notice that by combining the reactants and the products of the 2 partial equations, we get 2 moles of carbon reacting with 2 moles of hydrogen gas and 3 moles of oxygen gas in total, 2 from the first partial equation and 1 from the second, to give us 2 moles of carbon dioxide gas and 2 moles of water as the product. This exactly resembles the full equation given to us. To find the enthalpy change of this full equation, we need to add up the enthalpy change of the first and the second partial equation. The enthalpy change are given to us in terms of the equation given on the left. Because we multiplied the partial equations by 2, the enthalpy change should also be multiplied by 2. The total enthalpy change will hence be 2 times of the first enthalpy change of the first partial equation plus 2 times of the second enthalpy change of the second partial equation. In total, the enthalpy change should be a negative 1360 kilojoules for the full equation, leaving A as the correct answer.